I guess my screen is visible.
Yes, sir.
Doha is absent right now, no? She isn't here. Okay. Going to discuss the assignment by the way. So let's continue with some questions. All of you, turn your cameras on. Abu Bakr, Priyanka, turn your cameras on. Okay. Also, Abu Bakr, please try to upload your assignments on a regular basis. Some of the assignments which you have uploaded now, they are almost 1 month old. Okay. So try not to upload the assignments in bulk. Okay, try to upload it on a regular basis. All right. All right, guys. So look at the first question. The substance which reacts with oxygen giving heat is called as a combustible substance. Which of the following is a combustible substance from the given options?
Good evening, sir.
Yeah. Priyanka, repeat.
Sir, wood.
That is root option number D. Okay. So combustible substances are what? How do we define the combustible substances?
Sir, substances that can burn.
Or rather, substances that easily
Yes, sir.
catches fire. Okay, na?
Yes, sir.
Good. Other than wood, we have several other examples like coal, liquefied petroleum gas, kerosene, charcoal, diesel, petrol. Okay. Second question. Which
Sir,
one of the following?
LPG.
That is LPG. Okay, what about you guys?
Yes, sir, LPG.
Mustafa? LPG. Roughly, it is around 55,000 kilojoule per kilogram. Okay, na? Look at the table here. Here, calorific value of some of the fuels are given. For example, here the calorific value of liquefied petroleum gas, that is 55,000 kilojoule per kilogram. That is the unit of calorific value, kilojoules per kilogram. Okay, and the lowest calorific value is that of cow dung cake. Okay. By the way, we have learned about different types of coal also, right? No? Like we have peat, lignite, bituminous, and then anthracite. What do you guys think? Which one of these will have the lowest calorific value? Speak a bit louder.
Peat.
Peat,
Sir,
no?
peat.
Exactly, because it's the lowest quality of the coal, right now. So it will have lowest calorific value. Okay. Simply the carbon content in peat is very less and it contains lots of moisture in comparison to other types of coal. And anthracite, as you know, is the best quality of the coal. Answer this question.
Sir, C.
Option number C. And you guys? Everyone
Yes, sir,
have to
C.
answer. That is option number C. So as we have learned that magnesium deburn, okay, na, which when it is heated in the presence of air, so it reacts with oxygen and it gives out magnesium oxide. What do we call this? Magnesium oxide. What is the nature of magnesium oxide? Is it acidic or basic in nature? Haven't we learned about that? It is basic in nature, no? Right? Remember in the last class, in one of the previous classes, I told you that you can make a solution of magnesium oxide, you can dissolve it in water, then you will test it for the litmus paper. Okay. So since it is basic in nature, so which litmus paper are you going to use? Huh? Tell me. Will you be using the red litmus paper to check its nature, or will you be using the blue litmus paper to check its nature?
Sir, red. Yes.
A red litmus paper. Okay. And what about you guys? A red litmus paper, as Abu Bakr said. Okay, now when you will be dipping a red litmus paper in the solution of magnesium oxide, so it will be turning blue in color. Okay. Answer the next question. Which of the following is not a combustible substance? Which one of them will not catch fire, will not react with oxygen?
Sir, B.
Option number B. Very good, Pinker. That is glass. Na? While other examples like camphor, straw, alcohol, okay, like the one that you see here, no, that is camphor. Okay. So they are combustible. Answer another question. The substance that does not burn with flame.
Sir, D.
Option number D you are saying. Okay. And Mustafa, Abu Bakr. Camphor, you guys know, no? As you told me earlier, Priyanka, that it is used in prayers, no? Like it is burned,
Yes,
right?
sir.
Uh, and it gives flame while it is burnt. It gives flame. Liquefied petroleum gas, does it burn with a flame? We have LPG burner at our homes now. So the LPG,
Yes.
when it is burned, it gives flame now. Okay. Camphor, as I just said, when you will be burning it, it also gives flame. Okay, it also gives flame. Then look at another options here. Dry grass. So dry grass, if they were to be burned, will they not give flame? Whether
Yes,
it be
sir.
dry grass or wood, they give flame now. Okay. And last option is charcoal. Okay. So charcoal does not give flame. It does not burn with a flame. Or later, as Priyanka said, that is charcoal. So that is the correct answer here. All right. On placing an inverted tumbler over a burning candle, the flame extinguishes after some time. This is because of the non-availability of.
Sir, because of oxygen.
Obviously, oxygen is a supporter of combustion. No? Oxygen, as everyone knows, it is a supporter of combustion. And without the availability of oxygen, okay, no matter how much you heat the substance, if oxygen is not available, it will not undergo combustion. Okay. Like, can you burn something in vacuum? Can anything be burned
No,
in
sir.
vacuum? No. Next question.
Sir, C.
Hold on. One minute. Yeah. So that is option number C. Cover the person with a woolen blanket. Why not cover the person with a polythene sheet?
The polythene made out of plastic will catch fire easily.
Yes,
It
sir.
will catch fire, it will melt, and it will stick to the skin of the person, further making the situation bad. Okay. So hence cover the person with a woolen blanket. What is the principle behind doing this? Why the person should be covered with a woolen blanket?
Sir, cuts out the supply of oxygen.
Exactly. The substance expected to have the highest ignition temperature out of the following is kerosene, petrol, and coal. Three options are given. Like you will be needing enough amount of heat. Enough amount of heat is needed to burn them. You guys turn your cameras on, no? Abu Bakr and Priyanka. Hmm. Think logically, like if you were to given kerosene, petrol, and coal, these three types of fuels have been given to you. In order to burn them, suppose I have given you a matchstick. So which one will be difficult to burn with a matchstick? With just a matchstick, nothing else. You
The
only have
coal.
a matchstick.
The pearl.
Exactly, that will be coal, no? Right? Because coal has higher ignition temperature in comparison to petrol and kerosene. Higher ignition temperature means that it needs more amount of heat in order to be burned. Getting it? While kerosene, petrol, it can be just burned with a matchstick. With just one single matchstick, you can burn it easily. Okay, because it does not have a very higher ignition temperature. Okay. By the way, if a fuel's ignition temperature is same as the room temperature, is that a good fuel?
No,
If
sir.
the no, why?
That if it is the same as room temperature, it'll catch fire easily.
Exactly, no. So it will catch fire easily. So that is not a good fuel. Although there are some substances which are not considered as fuel, but they ignite at the room temperature. Okay, now upon coming in contact with air, they will just ignite at the room temperature. Like for example, white phosphorus, you guys know about it. It goes through spontaneous combustion, isn't it? Huh, Priyanka? White phosphorus, okay. If it is left exposed to the air, no, so it will burn in air. Okay, even without burning it with matchstick or bringing something else. Okay, choose the correct statement about inflammable substances from the following.
A. No, sir,
A.
no, sir. No. Sir, C.
Very good. So they have low ignition temperature and they can catch fire easily. That is the correct statement about inflammable substances. Okay. Now choose the incorrect statement from the following. Forest fires are usually due to. You have to choose the incorrect statement.
Carelessness of humans.
Sir,
Look at other options also.
Cutting of trees.
We have to pick the incorrect statement now, right? Incorrect statement. Okay, first look at all the statements. Carelessness of humans, yeah, obviously many times when people will be going into the forest for like either for picnic or for some adventurous exploration, so they will lit the forest, they will lit campfire. Okay, now they will lit some fire, and if it is not extinguished properly, so it can cause forest fire. So carelessness of human, that is a correct statement. Heat of sun, yeah, obviously heat of sun will dry up the plants. Okay, now, and thereby because of that also it can lead to forest fire many times.
So can I go drink water?
Yeah. Lightning strike, that also leads to it now. Many times you might have seen those videos that when a lightning strikes the plants, now the entire plant catches fire immediately. The entire tree catches fire immediately. So yes, that is also correct. Okay. And if one tree catches fire, the nearby trees are also likely to catch fire. So cutting of trees is the incorrect statement because cutting of trees is basically leading to deforestation. Deforestation. So in this, there won't be any trees in the area now. So if there isn't any tree, how can it how can it lead to forest fire? The calorific value is a fuel expressed in a unit called as. Hmm?
Sorry, sir, I joined late.
Okay, no worries. Everything good?
Yes, sir, I just had a weekly test.
Oh, okay. Oh yeah, Sana ma'am was actually telling me that you guys are giving a test. Yeah, the calorific value of a fuel is expressed in a unit called as.
Kilojoule per kilogram.
By
yes,
the way,
sir.
when you guys give a when you guys give the weekly test now, so is it that you guys give a live test and there's someone on the other side? How do you guys give the weekly test? Is it taken in Zoom meetings or you just upload the
Yes,
PDF
sir.
in
It's
the Zoom?
taken on Zoom meetings.
Oh, okay. Yeah, so for this it's kilojoule per kilogram. Okay. Give reason why water is not used to control fire involving electrical equipment. For example, if this electrical pole, okay, now here, this machine is on fire, so we should not be using water to extinguish it. Like we can use sand, right? We can use sand or some other types of extinguishers, but water must not be used. What is the reason behind this?
The water is a
So this is because water is a good conductor of electricity.
Hmm.
The firefighter or the person who is putting water on the fire might get an electric shock.
Hmm.
Yeah.
Good. So what is, as you guys explained, that water is not used because water, particularly if it is impure water, right now. So it's a good conductor of electricity. So throwing water on electrical fires, on electrical equipments that is on fire, can cause electric shock and can spread the fire instead of putting it out. Okay, now. So thereby, what is the alternative? What alternative do we have here?
Sand,
Fire
fire
extinguisher.
extinguishers,
Sand. Then particularly which type of fire extinguisher?
foam type fire extinguisher.
Foam type can be used, or you can just go for the carbon dioxide. So that one
Yes,
is
sir.
better. Okay,
So,
now. Uh-huh.
nothing. Sir.
By the way, foam type of fire extinguishers are also available. Okay, so that can be used here. Or dry powder extinguisher, that can also be used. Dry powder extinguisher here, basically, what are we using here? Basically, you will sprinkle some baking soda on it, right? That is sodium bicarbonate. So baking soda will be simply will be sprinkled over it. As you guys know that when baking soda is thrown over the fire now, so it breaks down and gives out carbon dioxide. Okay. Answer the next question.
Sir, but then it also gives out water, right?
It gives a water and it gives sodium. It gives out sodium bicarbonate also, but the amount of water given out is less. It is not that much. Okay, na? The amount of carbon dioxide given out is significant. It's much more than water. Okay. Second question: LPG is a better domestic fuel than wood. What is the reason behind this? Yes.
Sir, it has high
Uh-huh.
calorific.
So it has a high calorific value.
Okay, and
So easier to transport,
It's
easier to
easier
use,
to
easier to
burn.
ignite.
mm-hmm. Okay, lower ignition temperature we can add. Okay. Okay,
It is
and
easy to handle while
easy to
transporting.
good. Easy to store, easy to transport, as you guys mentioned, and some more points could be added here. As you can see that it has higher calorific value. Then you guys mentioned that easy to store and transport. Okay. Some more points were given by you guys. And what were those?
It burns more easily.
So suitable ignition temperature, we can say.
Yes, it
Suitable.
has a lower ignition temperature.
So it has a suitable ignition temperature. Good. And what about being eco-friendly? It does not give out excessive amount of toxic gases. Right now, it burns without producing any smoke or harmful gases. Right now, so LPG burns completely without producing smoke or harmful gases. While wood, as we know, it releases lots of smoke and can release and even releases carbon monoxide also, which can cause so many health issues. Now, so we will write down that it is eco-friendly also. It is eco-friendly also. That is simply environmental friendly. Okay. So burning LPG causes less air pollution compared to burning wood, and burning of the wood also leads to deforestation in a way. Okay. Answer the third question. Yeah. Question number C is saying that paper it by itself catches fire easily. Okay. You have a piece of paper, it will easily catch fire. Whereas a piece of paper wrapped around aluminum pipe does not easily catches fire. If you have an aluminum pipe like this, and around that aluminum pipe, you have wrapped paper around it. Okay. So this paper is not catching fire much easily in comparison to this piece of paper which you had. And here you have wrapped paper around aluminum pipe. What could be the reason behind this?
Sir, the aluminum pipe has a higher melting point, and because paper is so thin, it is basically the same as trying to burn the aluminum pipe.
Okay, but it needs some improvement. The answer is lacking some critical points. You guys, Priyanka.
So like you take a balloon and you put a fire right, and it'll burst out. It will burst. But if you put water inside it, won't.
So essentially, what is happening? What is the concept there? Like the heat is being absorbed by the water there. Priyanka.
So the heat is being absorbed by the aluminium pipe,
Exactly, Doha.
so the paper does not catch fire.
Just like moments you guys just said, as Mustafa gave an example. For example, you have taken a balloon, okay, na? Say that this is a balloon, and in this you have filled water. Now, if you were to bring a lighted matchstick, the rubber won't catch fire easily. It won't burn easily. Why? Because the heat is being absorbed by the water inside the balloon. So something similar is happening here. Okay, while here, paper having a lower ignition temperature, it will catch fire easily, right, everyone? It has a lower ignition temperature. Okay, but when it is wrapped around aluminum, the metal aluminum, being a good conductor, it absorbs the heat and conducts it away. It absorbs the heat and it conducts it away into the air. So this prevents the paper from reaching its ignition temperature. Although eventually after some time the paper is going to catch fire, but it won't catch fire immediately. It won't catch fire easily. Okay, na? So the absorption of the heat by the metal aluminum is lowering the ignition temperature. Okay, it does not let the paper reach its ignition temperature. So this prevents the paper from easily catching fire. Hope that clears it. Got it,
Yes, sir.
everyone?
Yes, sir.
Yes, sir.
Okay. Yeah. Look at this question. Yeah, Abu Bakr, tell me, you had some doubt?
Sir, I have a question.
Uh-huh.
Sir, like, sir, if you are heating water,
Hmm.
and then if we put another cup inside the water,
Mm-hmm.
sir, and then the cup is filled with water, why does the water inside the cup not heat?
Okay, not heat. Okay. So you mean
Yes,
to
sir.
say that you are boiling water, okay, in some kitchen utensil, and within that you have kept a cup in which you have put water. So why the water in that cup is not heating? Okay.
Yes, sir.
See, rather you should be saying that the cup inside the water will not reach the same temperature. Suppose you have a pot. See what Abu Bakr has been asking. Suppose you have taken a pot, okay, and it is filled with water and you are boiling it. Okay, say that you are boiling it, and within this within this pot you have placed another pot. You have placed another pot. That is what your question was now, right, Abu Bakr?
Yes, sir.
So Abu Bakr is saying that why does the water in this pot does not heat? Actually, this will also heat up, but the temperature acquired by the water in this pot will not be the same as the water in this pot. Getting it, guys? Okay.
Yes, sir.
So the thing is that as we are boiling it, so the due to convection now, due to convection, the water is going to heat up. It will heat and it will boil also. When the boiling point will reach, it will boil also. Okay. Also, in order for the water inside the cup to heat up, the heat must first pass through the metal of the cup now, through the material of the cup. Let's say if it is made up of metal or let's say glass. So before for the heat to reach the water inside the cup, first it has to go through the material of the cup now. So if the cup is made up of metal like aluminum, it conducts heat faster, so the inner water will heat. but more slowly than the outer boiling water. Getting it? Or now let's say that if the cup is made up of either glass or if it is made up of ceramic. You guys know about ceramic now? Right? Ceramic plates are there, ceramic statues or different kind of things are
Yes.
there. Okay. So
Yes, sir.
ceramic or glass, they are poorer conductors, right? Now they are much poorer conductors than other things. So heat transfer will be even slower. Okay, now. So the inner water, it will heat up, but it will heat up slowly because the cup here is acting as a barrier to the heat transfer here. Okay, now. Got it, Abu Bakr and everyone else?
Sir, but then
Yes.
my teacher said that it will stay the same. So like it will not heat at all.
No, that is not correct. That concept is not correct. How can it not heat up? Because think about this everyone, that this cup here, even if it is made up of glass or ceramic now, eventually it will heat up. It may not acquire the same temperature as the outer boiling water. If this boiling water has acquired a temperature of 100 degrees Celsius, so this may acquire a temperature of, let's say, 70 to 80 degrees Celsius, for example. But it will heat up. It is not like it will remain cold. In fact, we can perform this activity also in order to find it out. It's quite simple. Okay, now if you guys get time, try to do this, try to find it out.
Yes, sir.
Or getting it. Now let's come back to this question. So Doha, the question is saying now, Shyam was cooking potato curry on a chula. Chula, you guys understand now, right?
Yes, sir.
Right?
Yes.
In
No,
Indian,
sir.
no, chula is basically like this. This made up of, this is a kind of what do we say? It is made up of clay. We take clay and straw, okay, and we mix it and we make a chulha. Basically, it's very popular in Indian villages, in rural areas. Okay, they will be putting firewood or coal or cow dung cakes in it. They will heat it up and they will put the kitchen cooking utensil above it. So Shyam was cooking potato curry on this chulha. All right. To his surprise, he observed that the copper vessel was getting blackened from the outside. So he had placed copper vessel, okay, no, copper vessel, and it was getting blackened from the outside. So what may be the reason behind the blackening of the cooking utensil, that is copper vessel here, suppose? Although this is not copper vessel, but for the sake of understanding, assume this is copper vessel. So why is it getting blackened? Tell me
But
the reason. Huh?
option D.
Option D. That is not the right answer. No, how can it be option number D? You are saying no. Option number D.
Yes, sir.
So
What is burning
yes, I
here?
think
Fuel is
C.
burning here. No.
Yes, I
One
think so.
second.
C.
Uh-huh. See here.
Yes.
How can the
Sir,
copper vessel
improper
burn?
combustion of fuel.
Exactly, improper combustion of the fuel. Okay, na? So the copper vessel, the cooking utensil, this is not being burned. Actually, the fuel burns now, right? Also, the construction of this chulha is not very good. It has poor access to air. Getting it now? It has a poor access to air. For example, if I have to try and draw it, I have seen this many times while visiting villages. So this is the inlet where you will put the firewood. Okay, and this is the mouth. We can say where the on top of it the cooking utensil will be put. So the air supply is very limited. Okay, now so since air supply is limited, so thereby the fuel will not burn properly now. So improper combustion of fuel, and when the fuel burns improperly, it gives out unburned carbon particles. What does it give? Unburned
Carbon
carbon
particles.
particles. So the blackening of the cooking utensil is because of the deposition of these unburned carbon particles on them. Got it, everyone?
Yes.
Oh, mhm. Okay, let's finish this one also. Dash process in which a substance reacts with dash to give off heat is called as combustion.
A chemical process in which a substance reacts with oxygen to give off
Very,
heat is called combustion.
very good, very good. Okay, next one, Priyanka, you will answer, and see Abu Bakr And then D, Mustafa, you will be answering. Then E, Doha, you will be answering. Yeah.
Sir,
Yes, Priyanka?
so one fire.
Catches fire. Okay. Next. Mm-hmm. What should be the person covered with if they have caught fire, if they have catch fire?
Sir, woolen blanket.
With a blanket, with a woolen blanket particularly. Very good. Okay, next. Abu Bakr. The dash temperature at which a substance catches fire is called its.
Sir, for the first one,
Uh-huh.
sir, I don't know about the first one, but the second one is ignition temperature.
Okay. Okay, I will be giving you the options. Will it be lowest or highest in the first one?
Sir, highest.
No. Lowest, no? The lowest temperature at which a substance catches fire is called its ignition temperature. Okay, now please memorize the definition of ignition temperature. Okay. Next, Mustafa, the substance which have very dash ignition temperature and can catch fire easily with a flame are called dash substances.
So for the first blank, with very low ignition temperature, can
Mhm.
easily catch fire with a flame and are called inflammable substances.
Very good. Yeah, Doha, complete the last one.
So the substances which vaporize during combustion give flame.
During combustion, or particularly more appropriate, we will be using the word burning here. Okay, now?
Oh, okay, sir.
Because combustion, it's a broad term. Even combustion is happening inside our body also. Getting it? How does the temperature of the body is maintained? Anyone have wondered, like how does? It's an interesting question that how does the temperature of the human body is managed? Like how does our body produces heat? Our body also has a temperature, no? Right? What is the normal human body temperature?
37 degrees.
Very good. So how is this heat being produced in our body? Ever thought about this? All of you have learned about this. You guys have learned about this in 7th grade. Think about it. I will give some options. Okay. Multiple options will be correct here. Okay, na? Some options I'm giving you guys here. Is it because of
So during
mhm. Is it just because of physical activity? Is it because of cellular respiration? Cellular respiration? Is it because of um, thinking? Hmm? Or is it because of, let us say, choose the appropriate options from this? How is the heat being
Sir,
produced in our
cellular.
body?
so
Sir, question
digestion,
second one.
physical
Cellular
activity,
respiration, and
Yes,
then
sir.
and the cellular respiration.
physical activity and digestion can also be chosen here. Okay, as you guys know that every cell in our body breaks down the glucose, and that happens in the presence of oxygen, no? So in our cell, what exactly is happening? The glucose is being broken down with the help of oxygen, and in that
Sir, I
break,
have a question.
uh-huh.
Thinking produces electricity, right?
Repeat again.
Thinking produces electricity, right?
Thinking, it won't be correct to say, it won't, like it will be a general statement to say that thinking produces electricity. Yeah, it does, kind of like electrical impulses are generated in our brain, Okay, now every time we have a thought, so some electrical impulses are generated. Okay, so but it would be kind of a misleading statement. Our brain, it works through the neurons, it works through the nerve cells. Okay, and they kind of work, they kind of communicate using electrical impulses. They are kind of very tiny voltages. So like when you're thinking, when you're acting, when you feel something, so there are network of neurons in your brain, in your body, particular network of neurons in your in your brain. They will be firing up, they will fire the electrical impulses. Okay, so it's not that thinking itself produces electricity, but rather we should say that thinking is associated with the brain's electrical activity. Getting what I'm trying to say?
Yes, sir.
And that is generated by the neurons. So in short, like we can, I would say that neurons, they produce electrical signals, and those signals are what allows the thinking and other brain functions. Okay, so think about this. Like, isn't it kind of very interesting stuff? Huh? We study about electricity in physics, and you see on a very small scale, our nerve cells in the brain, they are producing kind of electricity. Hmm? So human
Yes,
body
sir.
is quite interesting. So glucose is broken down with the help of oxygen. It gives out energy. Okay, it gives out carbon dioxide, water, and it gives out heat also. Okay, na? So physical activity, cellular respiration, or digestion, we can say it produces heat in our body, and that is how the temperature of the body is maintained. And then let's say that if someone suddenly stops eating, no, someone has started to fast. Okay, like for example, if they have not eaten for a long period of time, for 2 3 days, so their body temperature will start to drop. Why? Because the rate of cellular respiration has dropped. Less cellular respiration means less heat being given out, and thereby the body temperature will start to drop. Is that clear?
Yes, sir.
Now answer this one. Why is the use of diesel and petrol as fuels in automobiles being replaced by compressed natural gas? Okay, in many vehicles now, when you will be looking at the back side of the vehicles now, so on the back side of the vehicles, you will find that there will be a big cylinder that will be containing CNG in it. Okay, particularly in these auto rickshaws, you may find it in the cars and some other vehicles also. So why is it being replaced? Why diesel and petrol are being replaced by
Because
CNG?
CNG is a cleaner fuel.
Hmm.
It's eco-friendly.
Good.
It releases less toxic gases. Like
Yeah.
it doesn't release that many gases.
Hmm. It reduces air pollution. Okay.
Yes, sir.
Hmm. So CNG, it burns completely and does not produce smoke or harmful gases like carbon monoxide, sulfur dioxides. So when CNG is burnt, okay, so upon being burnt, it does not give monoxide, or gives very less amount of carbon dioxide gas is given out. Also, it does not give out sulfur dioxide. What is this gas? Sulfur dioxide. It's one of the gas responsible for acid rain, as you guys would know. Okay, na? But petrol and diesel, they produces some unburned carbon particles also. Many times you might have seen that the exhaust of the vehicles, they would be giving out black smoke, right now. In many vehicles we have this exhaust pipe. You guys understand the exhaust pipe, right? So they'll be giving out this black smoke many times. Okay, even if they are using diesel or petrol, that may be because of faulty engine also. But burning of CNG does not give out unburned carbon particles that much. Okay, also, since this compressed natural gas is giving out very less greenhouse gases, since they are giving very little greenhouse gases, so it helps in reducing air pollution in big cities where vehicles are higher in number. Okay, no? Also, it is more economical also. meaning that it is actually cheaper. Actually, it is cheaper than petrol and diesel, and it is efficient also. Okay, na? You guys know about the term mileage, right? Mileage, you guys understand, na? Mileage, like
Yes,
for
yes.
example, mileage basically means, here in this sense, it will basically mean that how much, like how much of the distance the vehicle can travel upon consumption of a specific amount of fuel. For example, 1 liter of fuel. If the engine consumes 1 liter of fuel, so how long, how much the distance the vehicle will travel. So it gives better mileage also. So because of these reasons. Okay. As I said, we'll be doing some numerical problems. We'll be doing some numerical problems on calorific value. So I hope you guys know the formula, right? Let's do some questions. A fuel upon being burnt, a fuel, let's say here is of 18 kilogram. Upon being burnt, gives out 324 or 32,400 kilojoules of heat. You have to find its calorific value. Okay. All of you do the first question. If anyone doesn't know the formula, they can raise their hand. There's another question which I'll be giving you, but that won't be as simple as the first one. Okay. So I'm going to twist it a little bit. Say that a fuel has a calorific value of 44,000 kilojoule per kilogram. In this case, calorific value is given. Okay, next question asks how many, how much heat in kilojoule, kg stands for kilojoule, okay, na, is released by burning 0.25 kilogram of the fuel. Okay, hurry up everyone. kg here stands for kilojoule, and calorific value, and let me write down the formula also. That is equal to total heat given out upon amount of fuel. You guys turn your cameras on. Mustafa, Priyanka, and Abu Bakr. Done with the first question?
Yes, sir.
Good.
Yes, sir.
Good.
Done, sir.
Done. Good. You guys also done now?
Yes,
Priyanka?
sir.
Okay, let's start with Priyanka. Priyanka, what's the answer of the first question? Yeah. You guys tell me the answer of the first question.
So 1800
Hmm. That
kilojoule
is
per kilogram.
okay. Priyanka, you also got the same answer. Good. Okay, so all you have to do is basically divide it. Also, you guys know about the square of 18 now, right? Square of 18 is 18, right? 18 is squares of 324. So this 18 is going to cancel this by 18 and you're going to simply put these two zeros. So hence that is 1800. It is important to mention the unit also kilojoule per kilogram. Okay. So that is the calorific value. Next question. Yes.
Sir, 11,000 kilojoule per kilogram.
Okay, and you guys? Seems like you guys got
So
different answer.
11,000.
11,000. Okay. Abu Bakr, Priyanka. So
Sir, I was
calorific.
still doing the second one.
Oh, you're still doing it. Okay, see, we need to complete it quickly. See, the calorific value is given to you 44,000 kilojoule per kilogram. Amount of fuel that was burnt is given. You need to find out like how, amount of fuel that was burnt is given. You need to find out how much of heat was given out. Okay, na? So simply you'll be multiplying the calorific value with the amount of fuel that was burnt. So hence that will give you the heat. So upon calculation, you will be finding it out to be 11,000 kilojoules. Okay, now be careful with the unit. You'll be writing down the unit in kilojoule also only. Okay, now you're not calculating calorific value. So there you go. Here's the answer. If there's any doubt in it, no, like Abu Bakr or Priyanka, please tell me. Yes, Priyanka.
No, sir.
Good.
So when I got the heat as 11,000 kilojoules,
Mm-hmm.
then I tried to find the calorific value and
Continue. You're on mute, Doha.
oh, sorry, sir.
So
when I divided 11,000 kilojoule by 0.25, I got 440 kilojoule per kilogram.
How much you got? 440 kilo.
440.
Oh, you are not getting the same value.
Yes, sir.
Oh, seems like there's some error in the calculation. See, you're basically cross-checking it. Okay, now although here we have the answer, but for the sake of cross-checking it, you can see it like, okay. So you will put 11,000 here and 0.25 here. I have removed the decimal point here. Okay, now so thereby the numerator will be multiplied by 100, because after the decimal point there are two decimal places now. After the decimal point there are two decimal digits here. So the numerator will be multiplied by 100. This you know.
Yes.
Okay, now so thereby that is going to be 24 time 25 times 400, and you're again having 100 0, and that will be 440 multiplied by 100. So thereby we are simply going to put total number of zeros here, 44,000. Okay, I guess you had done some error in calculating Doha. Okay, now you
Okay,
can
sir.
just keep this in mind, like whenever you are dividing any given whole number with a decimal number, so after the decimal point you count how many decimal digits are there. Okay, okay, you write down the number without the decimal digit, and then the numerator will be multiplied by like 10 or 100. That will be based upon how many digits were there after decimal point. Two digits were there, so there will be 200s over, I mean to say two digits, two zeros over here, like that. Okay, we will quickly do this question. So define combustion, write the conditions necessary for combustion to take place. Say that this is a small 2-mark question. Okay, quickly answer it. We need to wrap it up. First of all, write down a short definition for combustion. Then you will write down the two necessary conditions for combustions are as follows. Point number 1, point number 2. Yeah, define combustion quickly. Yes. Combustion. What have we learned? We learned it's a chemical
It's a
process.
chemical process
Continue.
in which a combustible substance burns in oxygen to give off heat and light.
Good. Good. Or
And
rather,
other
we can.
byproducts is called combustion.
Okay.
The conditions that are necessary for combustion is the continuous supply of oxygen, the attainment of the ignition temperature, and the combustible substance.
Good. So first you will write down that combustion is a chemical process in which a substance reacts with oxygen to produce heat and light. Okay. Some necessary conditions for combustion are as follows. By the way, Doha, I wanted to discuss your assignment also. Okay. So you have to write down that presence of a fuel, that is will be combustible substance. Okay. Combustible substance. In bracket, we will write down that is simply a fuel. Second, presence of air. Particularly, it is being referred to oxygen. Okay. Although there's one more condition that is needed, required. Oh, question has, I thought question has asked about only two. So we'll write down the third one also. So third one was ignition temperature, right? The substance must be heated to its ignition temperature. Okay. Though the in your assignment, na, in question number 4, which you have uploaded today, not today, see, there's some error in it. The question was addressing what are the harmful effects of burning fossil and fuel. That was the question, I guess, yeah. But you have written only specifically about coal only. Okay, na? Question was particularly about burning of fossil fuels, like how burning of fossil fuel has adverse effect on environment. Question was of such nature, such type. So in this, you did not had to only talk about coal. Okay, now you had to talk about the adverse effect of burning of coal, petroleum, and natural gas. Okay, so you could have started that fossil fuels takes millions of years for formation. Okay, and upon being burned, they give harmful substances. Like that, you could have answered it. They give out harmful substances that causes air pollution, damages human health, leads to global warming, etc. Okay.
Okay, sir.
All right. So that's it for today's class. Some more questions are left to be done. That we'll be doing in the next class. Okay. And in the next class, we will start the revision of a new chapter. Okay.